So what is optimization? Optimization is to optimize. For example, car engineers want to find the least amount of fuel that you can put on the car so the car can move in a longer distance. Most optimization problem can be solved using the derivative. And optimization, we want to find the maximum or the minimum of a function. So what is a global maximum and global minimum? They also can be called as extrema or optimum values. So suppose a P point and the point is in domain of f. F has a global minimum of the value of the function at B is lower than or equal to all value of f. And then f has a global maximum at P of the function at P has a value that is greater than or equal to all values of f. Global extrema are guaranteed to exist using this theorem of f is continuous on a closed interval between a and b, then f has a global max and a global min on that interval. So notice that a global maximum or minimum happen at a critical point or an end point. Then how about if we have an open interval? If we have an open interval, an x between a and b, so the endpoints are not included, or the interval are all real numbers, there be might or might not global maximum or minimum. Now here, let's determine what's a local maximum and where is a global maximum or minimum. So at 1, we have a closed interval. So the closed interval here is going to be between a and b. So notice at their bottom we have a local minimum, and then in the middle we have a local maximum. Since the endpoints are included, this has to be either local maximum or minimum. So at B we have a local maximum, at an A we have a local maximum as well. So why it's a local? Because we are just talking locally to the point. So in local maximum, this is local minimum. So we're just talking in the values that is near local maximum and local minimum. Now let's determine what's a global maximum or minimum. On a closed interval, it's gonna be a critical point on the end or the endpoints. So here we see that the highest value of the function which gonna be at b. Therefore, this is a local maximum as well as a global maximum. Now, where's the lowest value of the function? We can see here is the lowest value of the function. Therefore, this is not only a local minimum but also a global minimum. Now let's move to 2. So here what we have an open interval, and that's gonna be between a and b. So here the endpoints are not included, so the endpoint will not be a global or local maximum or minimum. So here we only have a local minimum between a and b. Notice the endpoints are not included again, and these are not considered to be a local or a global maximum. Why? Because as the function increases at both ends at b and a, so as x goes to positive infinity or negative infinity, there is no global maximum. However, we can see there's a global minimum between a and b. This is an open interval, but it's for all real numbers. So we notice in here, this is a local maximum. And then here, this is a local minimum. And again here on the bottom, it's also a local minimum. Notice the endpoints are not included, so they are not a local maximum or minimum. Here they are a global maximum or minimum. And remember, local means just locally to the points where f is lower or higher than the adjacent points. Notice here at the lowest value of the function, where the local minimum, we have also a global minimum, since this is the lowest value in the function. And since the domain is all real numbers, so what we notice in here, as x goes to positive infinity or x goes to negative infinity, the function of x just keeps increasing. Therefore, we don't have a global maximum.